All right, can you still see it though?
Yes, ma'am.
Okay, awesome. I hate when it does that. Okay, so D says, suppose each section of the tape diagram represents 2 kittens rather than 1 kitten. Will that change the comparisons in part A and B? Why or why not? All right, so let's go back and look at that. So now instead of it being 1, 1, 1, 1, it's now going to be 2, 2, 2, and 2, which is what? 2, 4, 6, 8. And then this would be 2 and 2, which would be 4. Okay? So part A, we compared orange to black. So now my new comparison would be 4 to 8. Yep, hold on, someone's trying to get in. Aiden. Of course, it's not letting him in. Come on. All right, there we go. All right, so the new comparison would be 4 to 8, which simplifies to what?
1/2.
Yep. Is that what we got in A? Was 1/2?
Yes.
Awesome. Okay, so then it says, will it change the comparison? So we're going to put does not change. Okay, so part B, we compared orange to total. So my new orange is 4, right? So what would my new total be? 8 plus 4?
4, 8. Wait, 8, 9, 10, 11, 12.
Yep, so 4/12. And what does that simplify to?
2/3.
2/3? Should be 1/3, right? Yeah, 1/3.
Third.
Is that what we got in part B? Up
Yes.
top? Yeah. So
Yes,
nothing
ma'am.
changes. Nothing changes. And the reason why nothing changes is because we multiplied the original numbers by the same number. So what happened was when we ended up with, or we started with 2 4s, and I said, okay, now I'm going to double it, and we got 4 8s. Because we multiplied the numerator and the denominator by the same number, all we did was scale up that ratio. So when you multiply the numerator and the denominator by the same number, they are always going to be equivalent. Always. Does that make sense?
Yes, ma'am.
Yes, Aiden.
Can I have a second to get that down?
Yes. All right, so the 3 ways that we can write a ratio. You can use the word to, so 5 to 4. We can use a colon, or we can use the fraction, which is probably the most often way that you will see me using the fraction. Okay? All right, so it says a ratio can compare a part to part, a part to whole, or a whole to part, which is what we've been doing so far. So it says, complete the tape diagram to model the ratio of the number of blue squares to the number of white squares. So now that's going to be hard to see on here because you can't, my paper is in black and white. So we're going to try to do the best that we can. And let me pull out my actual copy so I can see what colors they are. All right, so we want to know blue to white. Alright, so this one is blue. This one here is blue. And this little one here is blue. Okay, so we have 3 blue, so I'm going to color the 3. And then the white are easy to tell, right? So we have 1, 2, 3, 4, 5 white, and that's what's left over. 1, 2, 3, 4, 5. And then my total would be 5 plus 3, which would be 8. All right, so now we're going to complete the 3 different ways to write it as a ratio. So what did they ask for first? Blue to...
The blue square. The blue to the white, so the blue is first.
Yep. So what would we have?
3 to 5.
Yep. So 3 to 5, 3 colon 5, and 3 divided by 5. All right, so if we were going to write that in words, we would say for every 3 blue, there are 5 white. For every 3 blue, there are 5 white. All right, so now it says write a part to whole or a whole to part comparison about the quilt using symbols and using ratio language such as for each, for every, or per. All right, so we are going to do part to whole. So pick a color. Doesn't matter to me what color. So somebody give me a color.
Blue.
Okay, so we already know 3 blue. So we're going to say for every 3 blue, there are how many total squares? Because this is a part to total.
8.
Not up here. Total all of the squares. Not the total blue to white. All of the squares. Yeah, because see, like this one is red. This one is red. This one is red. So the total squares would be, I think I heard someone say it, 15, is that right?
15.
Yep.
Yes, that's it.
Okay, so for every 3 blue, there are 15 total. So that's how you would write it. All right, so D says for every small green square, there are 2 large green squares. Does this mean that out of every one, there are that 1 out of every 2 green squares is small? So let's think about that. It says for every small green, there are 2 large. So is that right? So this one is green. This one is green. You can't see that, sorry. So green, green, and green.
It's right.
Yep. All right, so let's read it again. For every small green square, there are 2 large green squares. So does this mean that 1 out of every 2 green squares is small?
Yes.
How many green squares do we have?
We have 3, so wouldn't that mean 1 out of every 3 green squares is small?
Right.
Because those 2 green squares could be too large.
So no, correct. No, this is not correct. Hold on, someone's trying to get in. Oh, Clementine got kicked out. All right, you back, Clementine?
Yes.
Okay, I don't know what
Yes,
happened.
ma'am. Sorry, I accidentally clicked the leave button.
Okay, that's all right. All right, so no, it's not correct. So Aiden says it should say 1 out of every 3 squares are small. Because we have 3 total green and 1 of them is small. So that's what that should say. All right, so we are at the check understanding. I want you guys to take 5 minutes to work on that, okay? And then we will come. So what is the relationship between the tail and legs? What would we write?
1 to 4.
Yep, 1 to 4. Did someone write it in words?
I did.
Okay, so what did you write?
So, I put for every tail, there are 4 legs on a dog.
Yep,
Because he wouldn't say 1 tail. That sounds weird.
right. So for every tail, there are 4 legs on a dog. Yep, okay. What about number 2? Who did number 2?
Me? Also,
Okay, go ahead.
only parts, 8 cups of limeade plus 2 cups of lime juice would make the whole.
Okay, so is this a part to part or a part to whole?
Part to part.
Okay, so to make limeade, anybody know how to make limeade? What do I need?
Lime?
I need lime juice, I need water, and I need sugar to make limeade.
Oh, yeah.
So limeade is the actual drink. So it would be considered the whole, right?
Oh.
Yes.
Oh, I was gonna say, when you're done, can you go back up? I forgot to write something down.
Yeah. I want a minute. Okay?
Okay.
So limeade is the actual whole. And we need 2 cups of lime juice to make limeade. I don't know how much water and sugar we need, but I know that this part right here is the part. Okay? So it is 2 to 8, but it would be a part to whole. Okay? All right, so the on your own is very short today. It's only like 5 problems. Okay? So it's 1, 2, 3, 4, 5, 6 problems. All right, so I want you guys to work on that now. Now, I will tell you, when you get to number 5, it says, what is the ratio of 1.5 inch screws to 2.5 inch screws? They don't want 1.5 to 2.5. They want to know how many to how many. Okay? Does that make sense? So there's 36 1.5 screws, 24 2 inch, and 12 2.5. So they want to know what is the how many to how many of those screws. Okay? All right, get busy. I'm here if you need help. And Brianne, I think this is what you needed, right?
Yes.
Okay. See if they got it right. When did you go eat lunch? You're a 7th grader, right? So, you go after Miss Blue's class, is that right? Okay, so you have about 6 minutes. You go to lunch at 12:08. So you have a little bit of time. Okay? I'm going to catch up.
Mr. Dad, gonna let you know I'm doing this stuff for my workbook, so I can actually see the colors.
That's fine. Just make sure you take a picture of it, same way we did it if you were in class. Take a picture. Yeah, take a picture and upload it. That works.
For which one is it? Never mind.
Okay. So what did you do? Get to class late, and that's why you didn't know where you were supposed to be? I know, but somebody had to take her class.
Nobody was there. Oh, the whole class was at the door.
Oh, so you didn't wait for someone to come.
Yeah, I didn't wait. Well, I waited for a while.
I gotcha. Hold on. Yeah.
I don't understand number 6 on your own.
Number 6. It says, what is the ratio of the total length of 2-inch screws to the total length of all